In today's show, we discuss how old is the Earth really?
And now, the TNT Talk Show, daring to go where other podcasts fear to tread.
Hello, I'm Tony Fasulo, and I share the stage with my esteemed friend and colleague, Tayo Boya. Tayo, hello, my friend, once again. I hope you're keeping safe and well.
Yeah, I suppose.
Oh, that's a bit more positive to your normal.
Yeah,
Normal of
what the hell, Tony? Is all I can tell you. What the hell, really? The lucky ones die first and all that sort of thing.
Oh, dear. Anyway, I'm going to say hello to our audience. Hello, audience. I hope you're well and you're in for another fun-packed show.
Oh, fun. I've got something that's fun.
Oh, no, not another joke, please.
Well, at least you laugh. I always enjoy. I think I begin to look forward to these. Doesn't matter who she is, but Lucy got bombed, right? And where do you think Lucy went during the bombing?
Lucy?
Doesn't matter who Lucy is. It's just the name for someone who got bombed and during the troubles in in Northern Ireland. Where do you think she went during the bombing?
To the grave?
Everywhere.
Oh, that's horrible. I'm sorry, that's awful. Please, let's cut this now from now on. I'm sure that's awful. Stick to your day job, because clearly joke telling is not your forte.
Kablooey, baby, kablooey.
Oh, dear.
It's like the other one.
I have to apologize for my colleague.
It's like the other one. What's the last thing that goes through an insect's mind?
Oh, I don't know. I don't want to know.
No, an insect. Come on. What's the last thing that goes through it? Yeah, an insect that gets squashed by a windscreen. You know when you're driving your car, you squash.
Oh, don't.
What's the last thing that goes through its mind?
I don't know. I don't know why I'm going to ask, but you're going to tell me.
It's us.
Oh. You see, no laughter here, just groaning.
Every time I drive and I get a hit where I go boom. Oh, I know what just happened there. By the way, I don't know. Isn't there some kind of technology we can do to help people? They don't know they're hovering over a highway, do they?
No.
And then here's me coming down at 90 miles an hour. It's not going to help at all, is it?
No.
Anyway, at least they go quickly. That's an important thing. They don't suffer anything.
Shall we move on and dispense with this joke telling, which is really bad? Anyway, in today's show, we are discussing how old is the Earth really?
Mm-hmm.
And you got some strong feelings about this, haven't you?
Do you want
to kick things off? Or?
Well, no, I don't want to kick things off because it's your opposition to my feelings, my thoughts on this that is important. And the audience, I don't know what the audience would think at this point in time. I think by now they might imagine, I don't think they wouldn't be able to know. So anyway, talking to myself there a little bit, I think you hold what I would call the conventional wisdom position in this. I'm the one who disagrees with conventional science. So it's probably best if you say what you feel, because that's what I think most people would feel.
Modern science has worked out, and I'll explain later how they've worked it out, that the Earth is roughly 4.4 to 4.6 billion years old.
Bollocks.
Okay, let me go on then. Please explain why you think that is totally incorrect and you go against what science is actually saying.
I'm sorry, I'm still in a bit of a jovial mood. I have to pick up the mood because obviously my last insect joke didn't go down that well with you.
No, it didn't go down well with me.
You've killed the buzz. Buzz, get it? Buzz. Never mind. Exactly. Oh, well, now he's back. I get to laughing. Oh, no, so I'm not going to interrupt this time. Give us the conventional point of view. 4 something billion years ago, yes?
4 something billion, yes.
Mm-hmm.
Okay. And you're going to say why that is incorrect, because you're going to say that carbon dating is flawed. because carbon dating actually, just to answer your question in case that is what you're going to ask, carbon dating is only reliable up to 50,000 years old. Am I right?
It's not reliable at all, but 50,000 is the outer limit, is the upper limit for the theoretical, what's what I'm looking for? What's the word you used just now? Reliability. This is the upper limit for the theoretical reliability, but I argue that it's actually quite nonsensical all the way through.
Okay. And do you want to say what you believe the age of the Earth?
I believe that the age of the Earth is basically unknown, but that evidence points to a far younger Earth than suggested by conventional science's 4.3 billion years. I further argue, but I will not be arguing that in this particular podcast, in this particular episode, because of time restraints. But I further argue that the real reason conventional science claims that the Earth is 4.3 billion years old is so that there is enough time, theoretically, for evolution to work. Because a far younger Earth makes a nonsense of the idea of evolution. And that traduces, confutes, refutes their religion, which they pretend is a science. And that's the science, the false religion of evolutionism. But I'm not going to argue, I'm just stating, because if people want to know, well, why does science then say that it's 4.3 billion years old? The reason is to support evolution. They are changing facts and data to support a theory. They are not looking at the facts and data themselves.
Okay,
Scientifically and
you've made some interesting claims there. Do you want to back that up as to why you believe that science is coming forward with the wrong data?
Okay, let's think about this. If you want to age something and you want to know how can I put it? Okay, so we have to look for things which points to limit. We have to look for things that point to limitations, where we look at those facts and we go, well, in that case, the Earth can't be 4.3 billion years old. And if we find limitations which have no reasonable explanation, then we are reasonably sure that the Earth isn't 4.3 billion years old. Does that make any sense?
Yeah, it does.
Good. So I'm going to apologize to the audience ahead of time because you'll hear, if you hear that, audience, it's me not rumbling, rustling my paper. I have a lot of written notes here, and I'll start now. Spiral galaxies. That's the age of the universe, though, isn't it? Okay, I'll go back to that later because that's the age of the universe, not the age of the Earth. I beg your pardon.
Yeah.
Okay. My goodness, I went quite a long way before I realized that it was the age of the Earth I was going to be talking about. Okay, the age of the Earth, our moon. Let's start with our moon. Mm-hmm. It's moving away from Earth a couple of inches a year.
Okay.
If we do the sums, that would mean that if we run the clock backwards, it was moving away at let's say a couple of inches a year. We run the clock backwards. We'd assume, or we work out, that the moon was closer and closer and closer to the Earth, correct?
Okay.
Well, what is the limit, given where the moon is now, how much time could there possibly have been? If the moon came from the Earth, let's say that the moon was somehow ejected from the Earth, right?
Okay.
And moved away at this 2 inches per year thing. How long ago would the moon and the Earth have been in contact? It says that it was 1.2 billion years ago, not 4.3.
Okay.
So the absolute limit backwards is 1.2 billion years.
But wasn't it the fact that the moon didn't start moving away from the Earth straight away? Now,
when we are having this discussion, one thing is going to be that anything that I say, there can always be some story told. But the story that has to have some kind of evidence.
But your evidence of it moving away doesn't have a start point. It's
Well,
just a statement. It's moving away. So where did it start from? Based
well,
on your saying it.
it would have started from whenever.
Right?
And all
But
I'm
that
saying
means
is
a
that
constant velocity each and every time along the time period. But you don't know when that actually started, and nobody does.
no, we're not seeing an increase in the centuries. Well, I don't know if how long we've known that the Earth is moving away from the the moon is moving away from the moon is moving away from the Earth. But I have not read anywhere that it's accelerating.
It's not accelerating.
It's a constant. If it's a constant, then why are you introducing the idea of a reduced or accelerating pace?
If I remember rightly, I argued the point that it would get to a certain distance and then be held there. It can't go any further.
I love that. Now, the force of gravity is F. I know this from my school physics. F is equal to G m1 m2 over r1 r squared. Correct?
I can't remember.
I can absolutely. F is equal to G, which is this is the gravitational constant. M1 is the mass of the object number one. M2 is the mass of object number two, and is divided by the distance between the two, which is r. I don't know why it's r, which is radius rather than d for distance. Anyway, r squared. So, okay.
Okay.
The greater r is, the larger the square is. Correct?
Okay. Yeah.
So
okay.
making the force smaller.
Okay.
Now you're saying that it gets somewhere, and the more the distance grows between Earth and the moon, the less the gravitational attraction between two objects from this formula. This is in Newton's formula, I believe.
Okay.
Correct? And then you're saying that it gets to a certain place, and then magically and from somewhere there's enough force from something to hold it where it is. What force are you talking about? Where is it coming from? And how's it overcoming that motion away? Because the gravity is weaker at that point. And the further it moves away, the less Earth is going to be hanging on to it. I want to know where this magical force you're talking about to hold it in place is coming from. Over to you.
I don't know. I'm just I'm just throwing that out there, because otherwise all moons, if they did that, if he's saying it's just our moon or all moons.
We're saying it's all moons. I'm saying it's all moons. That's the funny thing about it.
How many moons haven't flung off and disappeared?
Because the universe is not 16 billion years old or whatever they're claiming today, and because the Earth is not 4.3 billion years old. That's exactly why. That's why Saturn still has rings around it, even though the rings are moving away from Saturn.
So give me a date of what.
How can I give you a date? I'm not saying it. I'm saying that it's not
disagreeing with the
4.3 billion. Yes, I'm saying it's much younger.
Oh, okay.
That's what I'm saying. That it's far younger.
Much younger mean in terms of dates?
Well, thousands of years.
It's only thousands of years.
It's only thousands of years old.
Oh, okay.
That's why we still have comets. Because comets should all have disappeared after 10,000 years.
Why?
Because each time they come near the sun, they lose material. What we see as the tail of the sun is material being burnt off by the comet's approach to and from to the sun and from the sun when it is leaving. So when a comet is headed towards the sun, its tail is behind it. But when a comet is leaving the sun's gravitational pull, whatever the orbit, the tail is ahead of it because material is constantly being burnt off.
Yeah. Right.
And clever clocks have worked out that all comets will be gone in 10,000 years.
That's assuming, and all comets start off at the start, and there's been no displacement later on. That's quite
well. No new ones anyway. I don't know about displacement, but no new ones.
How do we know the comets that we see now have been around since the dawn of time? We don't. They could have been formed at any point.
Well, we don't know what mechanism will form there. It's not magic, you know.
Well, it's smashing. Things still smash. We have an asteroid belt that surrounds between Mars and Jupiter, what we believe was an original planet at some point that's got smashed up. That's constantly smashing things up, and that's why we still see evidence of some meteors that come out of there and things like that. So it's an evolving beast. It's not something you can say, oh, it's only 10,000 years, so everything should be gone, because they're all created or come into existence, or whatever you want to use, at the same time. It just doesn't work that way.
They're actually orbiting, and we're going to see from the orbit that it did not start in this belt you're talking about. Because you look at the orbits of the thing, and you can figure out where at least the orbit does not begin and is not commensurate with what you're talking about. Because you're talking about something smashing.
Orbits are formed forever, or they don't just, once something becomes close enough to it, it gets swept into it and it becomes part of its orbit. That is what can happen as well.
No, I'm not saying that. What I'm saying is,
what can happen. For instance, on some examples, some of the moons may not actually be part of that original planet. But what's happened, the planet has brought them in because they happen to be sprayed out by some explosion, and now they become part of the planet's orbit over a period of time because the planet has sucked it in.
No, that's not what I'm saying at all. I'm saying that if your comments began, which they didn't, as some kind of collision between something and something else in this debris field, the orbit that we'd have seen isn't what we'd be seeing now. Because don't forget that when, let's say, Halley's Comet comes in, it comes in from way beyond the belt area, which have been the point of origin.
Yeah, that one does.
Well, I'm talking about, those are the long-tail comets then, aren't we? The what do they call it again? Long-lived comets. The ones that come from outside the solar system we're talking about. So the ones you're talking about would have been inside. And I don't even know why they even...
solar system. They're still in the solar system. Because they've been trapped by the sun's gravitational pull, and that's why they keep coming back.
Yeah, okay, not solar system. What's the thing I meant for inside the planet, not the planetary systems. There's a word for it. When you're inside Pluto, if you like. There's
our solar system, but there's still the sun's reach is still, it has some bearing even that far out. It's like they keep talking about planet number 9 or whatever it's called.
They're going to actually mention planet number 9 now.
We don't know if it's there, but
nobody knows if it's there. I don't want to get sidetracked. Anyway, because it's a very interesting thing. The word I'm looking for, the thing I'm looking for is the word I'm looking for means the planets that we're talking about with insight from Pluto.
Yeah.
The range of Pluto. And then there's another one that means, is it extra then? Extra solar? It means like it's coming from outside of that range.
Okay.
So even I suppose your famous planet 9 would probably be described as being that. And I can't remember what the bloody thing is called. Excuse my language. Anyway, if it's like snooker balls or something, you think of one that's close to the center of the gravity field and you smack it, it's not going to start off from inside that field, go towards the sun, find a lot of energy from somewhere, even if there's the slingshot effect. Yes, I know the slingshot effect, but it's not going to be enough to chuck it out all the way past Pluto again and then bring it back in again. It's what kind of science is, what kind of motion is that? That's why I'm saying
that's how Halley's Comet works.
No, that is, sorry, what? Excuse me, don't just bring that out from you. No, Halley's Comet came from outside. It already had the kind of velocity and everything we're talking about to achieve that kind of orbit around the sun. That's why it came from outside. And I'm not, by the way, I don't even know why I'm going through this argument with this way. The whole idea of your solution is wrong because even science has had to invent the Oort cloud. And if you were right, they wouldn't have needed to have invented it. They just have said, oh, it comes from this debris field, between Mars and Venus, right? Venus or something. Mars, Earth, was it? Mercury, Earth, Mars, Venus. Yeah, it'll come between Mars and Venus, which is what I think you're claiming. But no scientist is claiming that. That's why they had to invent the Oort cloud, and that's why they have to talk about the Kuiper belt. Because it's from outside, this blooming word, I can't remember, it's from outside that field that is limited by, let's say, Pluto. Okay, so we'll put that aside. Again,
the Oort belt is where it came from.
What?
The Oort belt is Oort cloud.
The Oort cloud.
The belt, yeah. The Oort cloud is where a lot of these long-tailed comets come from.
Yeah, long-lived, I think, rather than long-term. No, the Oort cloud is not where it came from, and I anticipated this, so I've got a lot of interesting things to say about it. First of all, I think the thing I love most about the Oort cloud is that her or Oort, he was actually Dutch, wasn't he? I don't know how they say Mr. in Dutch.
Okay, Mr. Oort.
Yeah, well, we'll use Mr. then. I wanted to use his name. Oort never saw the Oort cloud. Nobody has seen the Oort cloud. Astrophysics, Science, Space and Science, the magazine, volume 31, December 1974, pages 385 to 401, says the Oort cloud is based on mathematical errors, which have since been shown, since Mr. Oort spoke about it. I'll give you the reference there. Furthermore, this is Carl Sagan and Anne Druyan, D-R-U-Y-A-N, in a magazine called Comet, 1997, page 210, 1997, page 210. There is not a shred of direct observational evidence for the existence of the Oort cloud. Not a shred of evidence. It was a theoretical thing, just like you said, just like you went now to this theoretical thing about between the Earth, between Mars and Venus, as this yada, yada, yada.
Well,
it's like, yeah.
That's not theoretical.
No, I'm saying that it's the origin of, they're saying it's the origin of comets, and it's just like, no, that's just a story. That's not how it happens. And the Oort cloud is likewise a story that is attempting to save face and to explain why they're 10,000 years, why they're still comets. Really, we shouldn't see comets. And as I said, really, we shouldn't have rings around Saturn. Because
okay, you're now digressing because you're talking about the solar system and all that. But the topic of today is how old is the Earth really? I mean, you said it's less than the 4.4.
Well, we're talking about the moon. Remember the moon?
Yeah. Okay.
And then
the Earth, but okay.
Well, if the moon's recession, that's what it's called, isn't it? Moving away from the Earth. If the moon's recession limits us to 1.2 billion years, then we're certainly not 4.3 billion years. I mean, that's just certain, isn't it?
Well, do you know what the half-life of uranium is? Uranium-238
one of them,
in particular.
Is it 5,800 years or something like that?
No, uranium-238 has got a 4 and a bit billion year half-life. Uranium-235, however, is 704 million years half-life, and that is proven. And the reason how they work out the age of the Earth is by using a quartz crystal called zircon. Zircon is a very hardy crystal, and when it's created, when it's made, that mineral, it also has zirconium as part of how it gets its name, but in and amongst the lattice of the crystal is uranium, and uranium has similar properties. Let me finish. Uranium has similar properties to the zirconium itself. So when the mineral is first made from inside the Earth, before it comes out, it's got a lot of uranium in it. And uranium over time then gets displaced because of the half-life of it. And so what they found is you can find zirconium, different ages of zirconium have got certain amounts of lead in it. And lead is what happens to uranium when it's gone to its half-life. So the more lead contained in the zirconium, the younger the actual thing is. Older, apologies. I think it's that way around. So the more lead is discovered in the zirconium, you know that uranium has reached its half-life to become lead. So if you find zirconium and it's got a lot of uranium in it, then you know it's quite new. So it's quite young. But when you discover zirconium with a lot of lead in it, then you can work out the age of the zirconium. And when that mineral has been discovered, you can work out how old the planet of the Earth is. And some zirconium has been worked out to be 3 billion. Go on, you want to jump in?
Okay, so how, I asked the question earlier, but you sort of shut me down. But you'd have answered my question for me, which is, how did the uranium get into the zirconium in the first place? How do we know how much lead was in the zirconium when it was formed? And how do you know? Who was there? Who saw it?
Because there's volcanoes now that erupt, and you find zirconium now, and it's got uranium in it because it's new. It's been recycled from the Earth fairly recently. So that's how science has been able to determine, well, this is zirconium that's come around now. It's been produced in various places around the world, and that's how they know. And when they first get it, it's got a lot of uranium in it.
Does it have any lead in it?
When they first find it?
Yes.
No, very little, if any.
Okay. How then do you explain that when rock from Mount St. Helens, which exploded in 1984, was sent for radiometric carbon dating, it was dated at 2.3 million years?
That's correct.
Yeah, so how do you explain that?
Because it resets.
So the new rock from the new lava that you are saying is newly formed, is actually 2.3 million years old, and you're calling that as being a reliable methodology of measuring the age of the Earth?
Yeah, it's new.
How is it reliable when it is 2.3 million years old and has just been formed in 1984?
2.3 million hasn't been formed now. It's been building up in the
lava is new rock. Lava is new rock.
Yeah, but it's new.
It is new rock. Lava in 1984 should be, now in this year, should be, what is that, 40 years old? It shouldn't be 2.
It doesn't work that way.
Sure, it does. If there's no if there's no uranium or whatever it is, or no lead, whatever.
Lava, remember, it's not.
If there's no lead in this, as you're saying, because I want to ask you, how then do you know how much was there to start with? And you said, oh, there's nothing or very little. It should come back with zero. It should come back with...
Because it isn't brand new, because brand new is in the core of the Earth. By the time
all I'm trying to say is that's how rock is formed, isn't it? Isn't rock formed from new lava? Or are you trying to say that it's just always recycled? If it's always recycled, how come then in that case, why is it only 2.3 million years old and not 4.3 billion years then?
Because it's new recycled.
What do you mean by it's new recycled? Right. You can't have it both ways. Either the blooming thing. No.
2.3 million is young as far as rock is concerned.
You just said that.
Billion and million. Billion number is.
I know the difference between billion and million. Let's not pretend now. We know the difference between billion and million. You can't have it both ways. You're saying that we're recycling billions of years old rock, and yet when we recycle it, it doesn't recycle to zero as it ought to. It recycles to 2.3 million years. Why is it 2.3 million?
It depends how far down into the Earth it gets. If you've had a volcanic reaction, or hang on, if you've had a volcano or an earthquake, the rocks go back in, and if they've come under enough pressure, they will be recycled. Now, the lava itself, is moving. It's a liquid, isn't it? So it's rock liquid. It's not pure rock. It's not liquid rock, but it's still. Sorry?
Irrelevant. It's moving or not moving. Who cares whether it's moving? It's the age of the thing we're talking about.
Yes, it keeps reforming.
If it keeps reforming, then your 4.3 billion, if it keeps resetting or reforming, then your 4.3 billion years doesn't really work. It's either 4. What are you talking about? How can it? This really freaks me out, man.
Okay.
You're not. It's like you're saying that all the metal in all the world should have a certain age in it. Because it formed when, I don't know, iron formed.
Yeah, it's all different. Yeah, it's not all the same.
And yet, when we work on certain metals, we know when it was forged or whatever. We can say because it was made.
Okay.
And you're telling me now that it wasn't made? I mean, this is a zirconium thing and lead and all that.
Mm-hmm.
if lead is present in new rock, and by new rock, I mean rock that's just been recently formed from cooling down from lava.
It's not from
If
lava.
lead is,
this is a mineral, remember. Zirconium is a mineral. It's not lava.
so when it came from Mountain, when it came from Mountain Helen eruption, and the lava was pouring out.
Yeah.
I'm asking a simple question. When it came from that, should there have been lead in whatever it is, the zirconium, in that lava? And if there was lead, then it goes back to when I asked you, how do you know how much lead was in any sample that you've taken? If you're using a sand, what do you call it, a sand clock? Is it called a sand clock?
I don't. What that it drips? Yeah. It's
what's it called?
I know what you mean. When you turn it over, yeah.
When you turn it over, what the hell are they called? A sand? What?
No, actually.
Hourglass.
Not an hourglass, is it?
Is it? Okay. Well, I hope the audience knows what the audience knows what we're talking about. You have sand at the top, and you tip it over. I think it's called an hourglass, actually. You tip it over, and then it starts dripping sand at the surface. And then at the bottom, you can measure, okay? Mm-hmm. You got to ask yourself, what was at the bottom of that when we started measuring?
Right.
You assume it was empty if there was nothing in there.
Right.
And I'm telling you that we don't know. And you're telling me, 2.3 million years, because there will always be something at the bottom of the hourglass. Then the hourglass is not a reliable way of measuring time, because we don't know how much sand was at the bottom of the hourglass when we started.
Okay, so you're saying, therefore, that if the zirconium had come out in a Mount St. Helens, it should have been like 40 years old. That's what you're saying, basically.
Well, actually, in 1984, it should have been nothing. And when it was tested,
zero, it's not created at that point. It's still in the earth building. Yeah. So it may have taken thousands of years, in this case, millions of years, to pop out. And it's come out. Now it's already part of its journey. It's not fully formed. It's not at its old state, but it's already 2.3 million years old. But in terms of rock, or in this case, zirconium, it's actually very, very young. And you got comparisons of it all over the place. Hence why they can see different ages of the rock. They also do comparisons using other methods as well, just to gauge the age. But the thing that does them the best age is using, which they band it together as radiocarbon dating, but they're all different forms. They're using carbon dating as the term, but in reality, it's uranium lead dating for things over 1 million years old, because of the half-life of uranium-235 and uranium-238. That's how they can measure things that are older than 1 million years. And that's how we get the age of the Earth.
That is not my point at all. That's just not dealing with my issues here. My own issue is that you don't know how much. I mean, there shouldn't be any lead, or if there is, better than saying there shouldn't be any lead. My issue is that you don't know how much lead was in any sample of zirconium when you first start looking at it, and therefore you can't use it as a measurement principle. Just like the hourglass, if you don't know how much sand is at the bottom of the hourglass, when you look at it, it can give you a false reading. It will give you a false reading because you have no idea how much sand it had there to begin with.
And that's exactly what they said. Because of that reason, they don't know what the starting point is. But they have managed to work out the Earth is 4.4 billion years old. In actual fact, what they did say was, if they knew the zero rate of zirconium, the likelihood is the Earth could be even older than that.
Well, I don't think Mr. A.A. Snelling, geochemical processes in the mantle of the crust in radioisotopes and the age of the Earth. This is Institute for Creation Research, St. Joseph, Missouri, Creation Research Society, 2000. So it is Creation Research Society, published in 2000, pages 123 to 3. That's a lot. 123 to 304. I don't know who's going to read all that. Anyway, he says A. Snelling, by the way, Snelling, Snellling. He says lava flows that have occurred in the present and have been tested soon after they erupted have invariably contained more argon-40 than expected. For example, when a sample of the lava in Mount St. Helens crater that was, it wasn't 1984, 1986, sorry, that had been observed to form and cool in 1986 was analyzed in 1996. It contained so much argon-40, so this is not radioactive uranium.
This is potassium argon dating. This is
right.
Another form of radiocarbon dating.
Mm-hmm.
It's used by
and
archaeology.
The point said that it was calculated age of 350,000 years, which is a lot better than the 2.3 million years of uranium. Now, how come that people are popping up all over the place and saying this is a nonsensical science, my friend? Because, like Tony Fasulo says, we all know that it's just recycled earth, and is recycled recycled rock, and it should be that age anyway. Why are they expecting it to be far closer to the 10 years? Why are scientists themselves expecting it to be 10 years? If it's like you're saying, it's just recycled. Because lava, what is the temperature of lava? What is the temperature of molten rock? And argon is a freaking gas, for God's sakes. Why is it still in molten rock? It should have escaped. I mean, it should have been heated up and escaped.
Escape. If it's trapped in the rock, it's trapped in the rock.
How would it be trapped? It's not rock. I said lava. It's molten lava. And you see lava bubbling away. Blah, 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 blah. This is gases.
Looking at it,
these are gases escaping.
Yeah.
Right. So if you scrape it off you scrape off the lava at the top of the rock when it is cooled, where all the gas would have had a chance to escape. You don't have to go into the middle or the bottom of the lava. And you wouldn't expect any argon there. And yet, exactly as the guy says, that was the exact quotation from the guy, far more argon-40 than expected.
Yeah.
Well, then in that case, how are you so sure that your measurement techniques, how much time have you spent on this? Why are you so sure that you have been accurate? Because everybody else on my side of the argument feels that you guys are wrong.
Okay.
And we're saying that
give me a date on how you measure it. I'm telling you how it's measured scientifically. I want to know what your date is and how you measure it.
We measure it by the day that it was formed, that it was observed to be formed, because we believe in facts and evidence. And we look at it from when we can observe it, not by theoretical things that you say, theoretically, yada, 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 you get ridiculous dates. So I would have said the rock is 10. I would have said the rock is.
You don't believe it's there.
If I can't see it, I don't pontificate and I don't make statements and I can't back up. That's what I don't do.
You're backing it up with
You're not backing it up because you're getting
isotope dating, which is
so one. Argon-40 said was 350. Argon-40 said was 350 years old, but the uranium said was 2.3. What?
350 years old?
350,000 years. 350,000 years. And then your uranium said it was 2.3 million years. And then you're telling me that I'm supposed to take your so-called objective and scientific evidence? What's objective and scientific evidence?
That's half-life of the elements.
I don't care what it is, whether it's half-life. You're telling me that from one measurement technique, you're telling me it's 2.3 million years, and you're calling it science. And then from another measurement technique, you're telling me it's 350,000 years.
You said those. I never said those.
Excuse me, it's Mount St. Helens eruption, age of new rock. Google it, I'll wait for you.
Yeah.
No, Google it, I'll wait. And now I'm telling you, look now, Mount St. Helens, and I'm going to send it to you now during our chat
There's
thing.
Loads of other rock that's come out.
They're all given different years. They're all given different years. So I'm asking.
Because it's coming from different points inside the Earth's crust.
No, Earth's crust. We're talking about Mount St. Helens explosion. That's what we're talking about. Mount St. Helens rock that was formed after the explosion of 1986, not 1984, as I said earlier, 1986. That's what we're talking about. They took samples of rock. They aged samples of rock and they give it using different techniques. They get different ages.
How deep is the mantle in the Earth?
I don't care how deep the mantle of the Earth is. It's irrelevant. Do you not believe then that certain layers, it's in layers? Or not? It's not in layers. It's got nothing to do with layers. Just not for understanding what I'm saying. I send a car to three different garages for aging. Each garage gives me a different age. I'd have to wonder what kind of technique those garages are using.
Where are
Why are they
giving
giving
different ages?
That's what I'm saying, that when you look at it in argon, you get 350,000 years. When you look at it with uranium, you get 2.3 million years. And that's wrong. They should be giving you the same sort of,
no.
They should be giving the same sample, the sample from the same kind of rock, from the same rock, which is the Mount St. Helens, should be giving you the same age, or at least very close.
So you're saying, that's really interesting, actually, because you're saying that potassium argon was used to date the rock, and then uranium lead dating was used to do the same rock. That's really interesting, because they don't work on the same ranges.
What do you mean they don't work on the same ranges?
They don't work on the same ranges. You only use uranium lead dating when you believe that the item is more than 1 million years old. You wouldn't use potassium argon dating on items you believe are more than 1 million years old, because it's not as reliable as that. It's only reliable up to about 800,000 years. It's the same as carbon dating. Carbon dating is only sort of reliable up to 50,000 years. Each of the techniques are used at different points. They become less reliable.
So how old do you think that the recycled rock, according to you, should have been with the argon 40? Because you're telling me now you can't do it for less than 800,000 years. Are you saying that the argon 40 is wrong on new lava, on new rock that was formed in Mount St. Helens? Is that what you're saying?
I'm saying that it's not commonly used for dating minerals.
Okay, so it was used in this case, and I don't know. What do you mean it's not commonly used from dating minerals? Then what would something that is 800?
I'm talking rock. Sorry, not commonly used for dating rock, specifically.
What would it be used for then? Sorry.
It's used for archaeological stuff.
On what?
Well, fossils and things.
But how do you know the fossils are? How do you know the fossils are? Forget it. Okay. Anyway, if you look at it, from my point of view, the rock is, I don't know, 1986 to whatever the hell was. Okay. I counted the sums. 40. Well, how many years now? For God's sakes, whatever it is. Okay.
Right.
That's me. That's my technique. Your technique, which is supposedly scientific, we put it under argon testing. We get one. Right? Can we move on from this? We'll
I want to clarify just a point here. You use different tools for different instances, and the same with dating items. If you're going to be dating something you believe is within 50,000 years, then the best one to use is radiocarbon dating using carbon-14, because it's more reliable when something is younger, up to 50,000 years. Then between that and 700 or 800,000 years, you would use potassium argon dating. Anything beyond that, it's best to use uranium lead dating, which is more reliable on 1 million plus.
Well, first of all, since living snails have been dated by carbon dating technique at 2,300 years, I think we can easily dismiss that and just think, well, that's hogwash. And we know this. I mean, Google, again, for the audience members, don't take Tyre's word for it. It's very important what you Google. Just Google carbon-14 dating debunked or problems. And you're going to get a whole host of things where you just see that it's just nonsensical. There's so many assumptions that go into it. It doesn't, as one wag said, and I love what he said carbon-14 dating always dates items for which we know the age properly, but always misses the date when we know what the date is, but it's always correct when we don't know what the date is. And that's the situation. And I want to move on from this dating thing, because I think with that lava thing, it's just, I'm not sure that you really understood what I was saying.
I don't think you've understood how the mantle works, but okay, let's carry on.
Different dating techniques on the same samples give you different dates. Same thing with the moon rocks that they brought back. Depended on what dating technique we're using, even though it was the same rock. And you'd have thought that if your science was accurate, they would be somehow within range. And people can Google that too. Age of moon rocks. I don't know what you'd Google. Google age of moon rocks rendered different
radiometric.
There we go. Yes, thank you. Right. Now, oceans.
Okay.
Oceans are 3.6% salt. At the current rate of salination, that gives us an outer age of just 5,000 years if it started with fresh water.
Okay. So you believe that that rate, again, is constant, and you believe that the oceans are only 5,000 years old?
Well, let's put it this way. If they were older, where's all the salt?
But that's based on a statement you've just made that consistently means they started with fresh water and they became salty. How did he become salty?
The runoff from the continents and the, what do you call it, the silt and everything that runs into the ocean from rainwater and blah 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 is constantly washing off into the oceans of the world. This is how we call the salination of the world. This is the technique, not technique. This is the process which salinates the oceans. And there's a constant rate, there's not constant, but there's a rate that's been figured out by scientists. And
so you believe the scientists when they work that rate out?
Well, like I said, it's facts and evidence. You can check their work. I can check their work. Anybody can check their work. If I'm prepared to check anyone's work, it's when the work delivers. If someone was saying the salination is, I don't know, 30%, another person was saying salination is 60%, another person was saying it was 9%, then at that point I'd be saying that's rubbish science. But since nobody's contradicting the science, I'm quite happy to go with it. I'm a facts and evidence person. So oceans of the earth, 3.6%. In fact, I believe there's an article somewhere that says, why isn't the ocean, BBC, no, not BBC, sciencefocus.com. Sciencefocus.com. Are the oceans getting saltier? And I love this. Where's the question? As this process has been operating for billions of years, and there's no doubt that all oceans have got saltier over time, the real mystery is why they aren't now saturated with the stuff. You see how they don't bother to check their assumptions. They assume that's been operating for billions of years, and even though they're asking that question, then in that case, why isn't it saltier? They just can't get out of their own heads to question their own assumptions. And it freaks me out. It's like, look, my friend, look at your assumptions. People should learn how to write out their statements and underline the assumptions and then check their assumptions. This should be taught in school, should be hammered into people. Check your assumptions. Maybe your assumption is wrong. Maybe it has not been operating for billions of years. Maybe it's been operating for 5,000 years, in which case everything is consistent. And that's oceans of the earth are just, like I said, that's sciencefocus.com.
Did the oceans first appear 3.8 million years ago?
I don't know when the oceans first appeared. Like I said, I don't know how old the age of the earth is. All I'm looking at is how old could it possibly be? From that, it looks like 5,000 years. Now, I've never in my whole life been able to pronounce this stupid word. Desertification. Desertification. I'm not even sure that's right, to be honest. how it becomes a desert, right? Okay. Can you say the word? Because I can't. Desertification.
No, I can't.
Okay. The oldest desert in the world is the Sahara. And apparently is the geographical people and all those people, they say it's just 4,000 years old. The desertification of the Sahara is 4,000 years old. And once upon a time, Egypt was a fertile land. In fact, you and I have been looking at this for a different reason, which we don't need to go into now. So it's a bit strange that all over the planet, the oldest desert we have is 4,000 years. If it's millions or billions of years old, why? And by the way, I lived in northern Nigeria, as people should ought to know by now, and I know about desertification because you can see it happen. You can visit. There's a state in Nigeria called Katsina, which wasn't too far from where I used to live. You can go up to the border, and well, at the time, this was in the 80s, you could drive up to the border and see the desert sort of coming in, if you like. And now it's actually in Katsina. It's actually creeping. You can visit there like year after year and see with your two eyes that this desertification taking place. And if the Earth was millions of years old, why isn't that desert basically like in Saudi Arabia or wherever, or basically down to the coast?
Don't know.
Okay, yeah, exactly. Planes. Have you heard of the Lost Squadron? Not the Bermuda Triangle. So there's many of them apparently. Not the Bermuda Triangle Lost Squadron. This is the one that in the Second World War, 6 P-40 somethings. I don't know that they're kind of American aircraft, which I really don't know. The six of these P-40 somethings, P-48 or whatever they were, and 2 bombers, Lancaster, whatever. Again, I've forgotten the name. Flying Fortresses, B-52s, whatever they were. They left America. They were flying to Europe to go and take part in the war. They ran into a storm and they had to land. I believe it was in Iceland or somewhere. Anyway, they had to land. They were rescued, which is well and good, but they couldn't take the planes. The planes couldn't take off again, and they were left there. This happened in 1942. In 1990, a millionaire decided to dig them up, and he went over there and he found them. Guess what? 263 feet below the ice. 263 feet in just 40 years. Giving a rate of icification, which I can say, of 5.5 feet a year.
I've just seen an article, okay, that says, is it getting saltier? It's not. It's not getting saltier. So where are you getting your data to say it's getting saltier by 3.6% every year? No. The oceans are 3.6% salt. Okay. Not getting saltier. Okay.
But saltification is happening because obviously, my goodness gracious me, who said that the oceans are not getting saltier? What kind of buffoon is that? Is he saying that stuff doesn't run off into the oceans from rivers run into the oceans, right? And they take material with them. That's salification right there. So how can anybody say it's not getting saltier? I mean, salts are going into the ocean every year from rain.
Yeah, but the ocean salt isn't getting saltier. It's not.
Well, it must be getting saltier because more salt is going into it. It's not magic.
No. Okay.
It's science, man.
Oh, okay. So you believe that science, though? So
yeah, like I said, it's facts. It's facts and evidence.
You're picking. You know,
I'm not picking. I don't have to believe everything that is scientific, supposedly scientific, because somebody says so. Everything that somebody says has to be tested by logic, and we then take facts and evidence. We believe the things that are factual, and where there's evidence, and we throw out the nonsense that doesn't have any facts and doesn't have any evidence, or has contradictory evidence. That's actually how science ought to work. People ought to say things and make claims, and then we test them, and then we say this is right, and we say this is wrong. That's the scientific method. The scientific method is not taking somebody in a white coat who says this is how it is, and going, well, okay, you're a scientist, and therefore I agree with you. That's not how it works. And I want to talk about the planes. 5.5
running
feet.
Out of time here, so you need to.
I have hardly said anything.
Quick. Well,
5.5 feet per year, and the ice poles, all the ice at that rate, all the ice under the poles, both poles, would have been formed in less than 5,000 years.
Are you saying, therefore, that the planet Earth is just 5,000 years old, which is what you're trying to conclude from?
I'm looking at the facts and evidence, and I'm seeing a repeated thing. The oldest tree in the world. This is Allen and Bacon Biology, 1977, page 180. The oldest tree in the world is 4,300 years old. The Mississippi River dumps 80,000 tons of sediment every hour. Every hour, Tony. Mm-hmm. Every day, every month, every year.
Yeah.
If the Earth is billions of years old, why is the Gulf of Mexico not completely filled in?
What?
Why is the Gulf of Mexico not completely filled in if it has been filled up at the rate of 80,000 tons of sediment every year? What we have seen and what people have calculated is that the amount of mud at the bottom of the Gulf could have been formed in just 30,000 years. Well, has been formed in just 30,000 years, given this rate of sedimentation. Just 30,000, not millions of billions. So what happens to the millions and billions of years then? Yeah. Niagara Falls is eroding at 4.7 feet a year. It has eroded approximately 900 feet since 1764, when I think the first reliable map of the place was drawn. And this is available to people to see for themselves in the Niagara Falls Museum Guide. If the Earth is millions or billions of years old, why hasn't the falls, because it's the falls, eroded back to Lake Erie by now?
Because did it start billions of years ago, or did it start later?
I don't know. It's your.
There you go.
It's your.
So you're making an assumption.
Well, yeah, my assumption is that the river has been there.
It's been there for billions of years.
And so, what are you saying it was formed?
Not billions of years ago.
So it was only formed just long enough ago for it, even if it was like, so if it's 4.7 feet and it's got another, what should it be? I should have anticipated the question, my fault. I'm going to work out, I'm not going to work, I'm going to bother, but anybody who wants to work it out can look at where it is now and look at where it will meet Lake Erie, work out the distance, and then see how long it will take. And then work backwards to see, well, then in that case, when was that river formed?
That's not okay. All right. You can use whatever pseudo way of thinking you've got.
You just invented something out of nowhere. You've just said that the river wasn't always there. All we've ever seen, all we've ever observed is the river being there. And you've just observed that, no, it wasn't always there because it doesn't fit your model. I'm not the one changing. My model is fine. My model is that this is the rate of erosion, and therefore this is the limit. And then you're going, well, maybe it's, so you're the one with the maybe, not me. Okay. And then you're trying to put it on me now. That's a fallacy.
How half-life of uranium then can be explained?
I don't know where the half-life of uranium comes from, and I think we spend enough time on the half-life of uranium because all I'm trying to tell you is that it's not relevant from my point of view.
Right, from your point of view, but it is relevant from my point of view.
You are saying that the thing was there. You are saying that I'm saying that it shouldn't be there because, as far as I know, from the mechanics of forming lava, and I'll put it back. Let's not even get ourselves confused. Let's stop all this uranium. Your uranium clock thing is like this hourglass sand, the sand in the hourglass. All I want to know from you is, how do you know how much sand was at the bottom of the hourglass? That's it. That's all I want to know. How do you know what exactly? Therefore, your hourglass model is completely irrelevant.
No, it's not.
You don't know.
From that starting point, assuming
what
that
starting
is
point?
Zero.
You assume. I'm not going to follow any of your assumptions.
They've never ever said they're going to be totally accurate.
I will never accept your assumptions. Okay. Why should I? You just told me to take facts and evidence. That's not a fact. That's not evidence. That's an assumption.
Okay.
Can't you tell the difference between facts and evidence and assumptions? Just like now, when I told you about Niagara Falls, you are the one that wanted to start bringing in your assumptions. Well, maybe then it wasn't starting. That's an assumption. I don't know all that. What I know is the facts and evidence are this. When you look at an hourglass and tell me it's been going for 1 hour, you are accurate if you tell me that it started out empty. But if it did not start out empty, you can't tell me it started an hour ago. Maybe it started 2 seconds ago because there was already an hour's worth of sand at the bottom. So why should I accept your assumptions? Why should I? We're looking for facts and evidence. Like about this person with the salination of the sea. We can see for ourselves how, operating for billions of years, he's confused as to why the ocean is not that saltier. The only reason he's confused is because of his assumptions. Okay. If you don't take that assumption, there's no problem.
Okay. We've come into the end of the show now. Do you want a final sum up?
Continents should have eroded flat in millions of billions of years. At the rate of the current erosion of continents, we should have eroded flat in 14 million years. I didn't get. Oh my God! I didn't put the reference down. We should have, but I'm sure people can Google it.
Okay.
The continent should have eroded flat in 14 million years. If we are so much older, why are there fossils that are supposedly 300 times older found in rocks on the continent, found on continents? If as all the assumptions that people are making are right, there's something wrong with the assumptions. There's something wrong with the model. From just going by the rings around Saturn, recession of the moon, this starting from outer space, comets, going from that and then coming down to Earth, there are many, many indications that there's something very, very wrong with an old Earth model.
Unfortunately, with that, we have reached the end of the show for another week.